Good morning. I'm Jim Carefoot with Armada Technologies, and welcome to our Find It, Fix It Friday, 30-minute sessions we do every Friday on some topic of interest for testing in the green industry in particular. And today our topic is differences between troubleshooting multi-wire irrigation systems and two-wire. We've had a lot of questions recently about two-wire troubleshooting. We have a little training course that we do on troubleshooting two-wire, but today we're just going to do 30 minutes, kind of blow through it and talk about the differences, because we're test people and it's about what kind of test equipment and process is different between these two. So we have everyone muted because the number of people on here. You're welcome to use your little side control panel on your screen to send me a question by message box. I can handle that at the end, and if you raise your hand at the end using the little control panel, I can try to unmute people and answer questions. So we'll keep it under 30. Everybody's time is valuable. So with that, we're going to. I should also mention, if you can see me in a little webinar photo thing on the in the corner there, you don't need to watch me. You can always minimize that so you can see the slideshow, which is the important part. So we're just going to go through some slides and narrate it a little bit today. And I think that all of you are probably familiar with the two classic types of irrigation systems, the multi-wire, what I call a conventional irrigation system that people have used for a long time, and the two-wire, which is a somewhat more complex and bigger type of a system that is more common these days in certain applications where it's economical, like golf courses, big parks, business parks, that sort of thing. Where multi-wire starts to struggle to get the same kind of size and reach. So the multi-wire application is, you can see on this slide here, multi-wire control of what I call a wire per valve. So each of the valves in the field is remotely controlled, has one wire running to it, and there's a common wire that connects them all together. So the multi-wire controller lets water into the zones by applying 24 volts on the appropriate wire. It causes the valve solenoid to pull in, open the diaphragm, and water flows. Something I think probably most folks are familiar with, although we have a little class that we do too on troubleshooting this kind of system. A two-wire system, as you see here, is different primarily in the fact that it uses one control cable that just has two wires in it. We're literally talking about a computer-controlled local area network. The two-wire controller here is a smart system that has all these slaves that we call decoders that are in the valve boxes, and these decoders are actually the ones that activate the valve solenoids. So very different kind of a structure. Got a couple of diagrams to help illustrate the difference when you get into the field. One control cable, a long string of decoders that fire the valves based on their commands from the two-wire controller. So all of this stuff, of course, is underground or flush level valve boxes, and you need to find both those paths and the valve boxes in order to do your troubleshooting. So this diagram helps illustrate the difference between the wiring in these two systems, which makes a big difference in how your troubleshooting goes too. In a star home run conventional conventional multi-wire system, you've got a common running to every valve in the system, and you've got a single wire running to each of the valves independently, so they're fired with 24 volts. So they're fanned out, kind of spread out, what I would call a star configuration, or all the wires home run. In a daisy chain arrangement in a two-wire control system, you have one control cable that just runs from valve box to valve box, and depending on how things are laid out, these wires may be operated in kind of a loop or a Y or something, but it's really basically a chain of decoders with valves. So its topology or physical layout is quite a bit different. As you can see in the diagram there, it illustrates the same property done with two different types of systems. So whether you're doing one or the other, whether it's two-wire, whether it's a conventional system, you've got some of the same kinds of problems you have to solve. And is the system dead? And why is the system dead? Is the controller the problem? We always say in the troubleshooting end of this stuff, and I have a chart to illustrate this a little bit later. You always start out at the source of the power and work toward the field. So you're always looking first at the controller. If somebody's popped the circuit breaker and the controller's dead, or someone's got a rain sensor unplugged, who knows, but the controller can stop working. These are all kinds of things that you need to do that's in common with any irrigation system. Faults in the buried wire, that's one of our fortes, is tracking and finding faults in valve boxes. So locating where all these things are is the beginning of your troubleshooting once you get away from the controller. So same old problems. I've made a bullet list here of the differences between a multi-wire and a two-wire system, kind of listed the multi-wire and then the two-wire. I won't read the list of bullets, but you kind of get the idea, the difference between them. That the two-wire system has a single cable with two wires in it for control and power that daisy chains all the valve boxes together, whereas the multi-wire, what you're more familiar with probably, has a wire per valve with a common wire. So that's a pretty fat bunch of wires. The multi-wire turns on valves with a shot of 24 volts AC, and the two-wire systems commonly have something over 30 volts running on their control cable, and that voltage is led out to the valve to close the valve based on the command to a decoder. So literally, when you start working on two-wire systems, you're kind of becoming a computer technician here and having to troubleshoot the computer system and data communications and the slaves. So in that regard, it's somewhat different. One thing I should mention as a difference between the two systems, too, is that 30-some volts that's on the control cable is there 24/7. It's there constantly. And what that means is that the splices become more critical. The splices that are powered constantly, they get wet and there's moisture in the air, that encourages corrosion with the copper. So what you have to do is use a very high-grade DBY type splice when you're doing wiring between the control cable and the valves. That's a main difference, because one of the biggest failure modes in a two-wire system is exposed copper or damage to the splices in the valve box. So there's a list of these things. We'll be posting a recording of this slideshow and discussion this morning on our YouTube later on today. So you'll be able to see this. You don't have to try to screen capture or do something if you wanted that list. The names of people who make two-wire systems are pretty much the names that you see in the regular irrigation world for valves and controllers and all sorts of things. Hunter, Toro, Baseline, Rainbird, all our usual friends are there, and each one of these systems is a little different. They're all smart systems, and they have to drive their own decoders typically. So you have to know what kind of system you're in. You don't have to take the multi-day training class that these guys offer necessarily in decoders to do a little troubleshooting. You can go down to and sit in a Hunter class for 3 days. They'll tell you how to program it, how to troubleshoot, how to design the system, everything. We do a little class in troubleshooting that takes less than an hour, and today we're doing this in 30 minutes, and we're not detailed troubleshooting, but it's the 80-20 rule. You have to get a leg up on this thing. So as with any kinds of the field systems like this, the process for doing troubleshooting in a two-wire controller is start at the power source and work toward the field, even in the two-wire system. So the difference in a two-wire system is that the controller is much more sophisticated than the basic clock that you'll see even in more recent model versions of a conventional irrigation system. It's pretty smart. It has built-in diagnostics. So when we tell people get started on troubleshooting this thing, always start at the controller and let the controller tell you if it thinks something is wrong, because it may identify things for you. It may tell you what zone and valve has got a problem. It may tell you there's an overcurrent situation. It's a good beginning with a two-wire system. And working your way out toward the field wire, you need to disconnect the cable, do the resistance measurements, that kind of stuff. And that'll be common to all of these sorts of systems. Check each wire to ground. You want to have a good half megohm, that kind of stuff. You're looking for places where there's a leakage to ground, a bad splice in water, a nicked cable, that kind of thing. And you need to find the decoders. And one of the main differences between a two-wire system and a conventional system when you're doing troubleshooting is that you cannot find the valve boxes with a locator. Our locators are called wire and valve locators, but that is true in systems where the valve solenoids are wired directly to the system. But in a two-wire system, you cannot find the valve box because it's hidden behind the decoder. And a little diagram to illustrate that later when we get into locating tips. And the valve solenoids, once you find the valve box, that's where all your issues probably typically are. If you've got a bad splice, you've got a solenoid that's gone bad, you have a valve that's got a torn diaphragm, all that stuff, all that treasure is in the box. So you still have to have a way to find the valve boxes. We're test equipment folks, so that's what we're focusing on here. The things that you can still use that you've always used with systems that hopefully you have. For example, an electrical meter. I don't care if it's a Harbor Freight $10 special electrical meter. it's a good thing to have. You're going to have to check voltages and resistance anytime you're doing troubleshooting. Somebody with you or in your vehicle has got to have a meter. Solenoid activator is great, good for conventional systems, but it allows you to test the solenoid at inside the valve box to figure out whether you've got a bad decoder or a bad solenoid. So still useful. Wire and valve locators, no matter what you do, you still have to know where stuff's buried, and that means following the main path of the cable. So you got one of those, you have access to one, you can rent one, you're good. Pretty important. A ground fault locator is another big deal, because some of the damage that occurs in the field is damage to cables. Besides having a splice issue, and you can even find a wet splice using this actually, leads you to a place where the insulation's been nicked or the wire's been cut. Great thing, works with all these systems. But when we get to two-wire systems, there are a couple extra items you need to know about, and I've got a picture of some of these here as we go forward. A milliamp clamp meter is something that's critical, especially since we're really concerned about the splices in the system. We need to be able to find out what's going on in the system's control wiring without opening splices. So a clamp meter is the right answer here, because it clips over the wire without having to do any kind of wire skinning or opening of splices, and furthermore, it has to be very sensitive RMS clamp meter that allows you to read the tiny currents that are flowing through these two wire systems. And by tiny, I mean every one of these decoders can consume as little as a milliamp or even less than a milliamp. So you've got a chain of 100 decoders or valve boxes out there being driven by the controller. That's 100 milliamperes, so that's a pretty respectable current. But you need to be able to go from box to box and read the decrease in current as you get further into the field, or find the places where gross currents are sliding to the ground because of a wet splice or a cut cable. Anyway, this meter becomes a critical factor, and it's recommended by the IA. This kind of a test meter is also recommended by manufacturers like Reinbird and Hunter. So good thing to have if you're going to do this stuff. 24-volt power source. Now, what you'll also hear from the two-wire vendors, and it's an excellent idea, is to have a power source there so you can power the field wire up separately from the controller. You're disconnecting from the controller anyway to do locating, to do some resistance checks, but if you want to get out there and start feeding some current and voltage down the wire to help isolate problems, putting your own 24-volt power supply on the line is a good idea. And you can get these things for less than 20 bucks. We've got a picture of one later. Lets you do troubleshooting independently from the controller, because the controller, if the system's kind of gone really flaky, the controller will let go anyway and it won't supply power, and you have to have power on the cable to troubleshoot. So another item that we've got that I'll touch on at the end is wire radar. So since we can't find valve boxes using a locator in the same way we used to, something that can be pretty handy, we've had some customers that had good luck with this, is use a TDR, time domain reflectometer, or a wire radar that pings down the wire and tells you distances to faults, including splices, even good splices, so helps you find valve boxes. Great little, all these things are time savers. Some of these things you could probably figure out with a shovel and a backhoe, or a little ohmmeter after a while, but every one of these things is going to help you with your troubleshooting speed. So among the tools, little diagram here, the tools that you've got that you might have used for a while: the locator, the ground fault finder, like that A-frame on the right. Our Pro 800D is our most popular locator now because it has wireless connectionless tracing. It has regular tracing. It has a peak and null mode antenna switching, which has some surprising benefits. And in the middle are the things that pop up when you get into the two-wire system. And there is that true RMS milliamp clamp meter that I talked about. The Pro 93 is our model, and it is commonly used in training and demonstration in the field for finding faults in a two-wire system, without having to open up connections. Great tool. And there's a picture of the little handheld wire radar toward the bottom. Another kind of a nifty thing, but it takes some doing to figure out. You have to be experienced to know how to use it. We stole this from the cable TV business, where we sell a lot of them, and very useful for those folks for finding places where wires have been crushed and cut and the distance to them. So the clamp meter, again, one of the tricks, we sell several varieties of clamp meters, and this is the Pro 93 for the two-wire is the most expensive and the fanciest, but they all work by clamping over one of the pair of wires. Now, we've got two wires going out into the field in a two-wire system, obviously, so we got to clamp over one of them, and we can read, without interrupting anything, read the amount of power being fed to the field through this. I can also go back up to the controller, plug the test leads into this, and read the voltage going into the field, which is one of the first things you do. But out there, clamping over the wire, very good, non-invasive way of finding out if the power is flowing up from box to box down the chain as you expect it to. So this is a good illustration of what very often happens in a basic two-wire system. You've got a controller at one end and a long daisy chain of valve boxes where the power and control signals are dropped off in each one for the slave decoders. And the controller sits at one end and says, okay, I need a water valve 16. So it looks up the address, sends a signal to valve 16 and says turn on now. The valve turns on just like it was being powered in a conventional system. Water flows. So all the programming in a two-wire system, that sort of stuff is done in the usual way, setting up a range of days and hours and that sort of thing. It's just the control mechanism that's different, and unfortunately for you, that's the part you have to solve. So you become kind of an electronic technician for data networks practically when you do this, but we're usually hunting for wire problems. The most common problem in a situation like this is a bad splice, because of the constant power and current flowing through the system and the corrosion mechanisms that go along with copper and other stuff. DBY splices, just to list one manufacturer. So cable damage, cuts, skins, bad splices, bad decoders. You'll find things out there that you're not used to seeing sometimes. Lightning protection, ground protection. Normally you shouldn't have to worry too much about this, but because of the electronics in the system and the length of the chain, they put lightning protection in because they're pretty easily exposed to lightning, especially golf courses and business parks that they have thousands of feet of run of this cable. So that's what you're going to be facing. Here's a little troubleshooting diagram that we use when we do the training on two wires, just to give you an idea of the things that you start out doing. And as like I said, start with the controller, because you're going from the source of the power toward the field application. So making sure the power is okay, things are coming out of the controller okay, the controller thinks everything's fine, or you know, it's working at least. And you get down to where you're troubleshooting the field cable. And there's a little picture there that shows that test power unit that I mentioned. You may need to carry a big extension cord in order to get power to this little unit, unless you've got some other 24-volt AC signal generator. But it's worthwhile because you can put your own signal on there that's very easy to measure, and the controller doesn't have to be working. It can be dead, it can be unhappy, it can be disconnected for safety, whatever. But you use this little power unit to apply power to both leads of the main control cable, and it allows you to do the same measurement with the clamp meter. Do I have too much current flowing? Is there excess current on one side of one of the wires and not on the other? Is there a very low current, meaning I've probably got a cut up ahead somewhere and some of the decoders have been isolated and they're not consuming as much power as they should? You've got a string of 100 valve boxes or something running down a golf course, and each of the controllers is sipping 1 milliampere piece. That's 100 milliamperes. If you've lost 50 milliamperes, you can figure, wow, it's probably somewhere in the middle of the chain. That's the kind of stuff you're doing. You have to be a little bit of a detective in order to get this stuff done. So here's just another illustration of the clamp meter in action. You can use the voltage test, as you can see, to do, and you should. Go to the two-wire controller. Systems vary a little bit, 32 volts, 36 volts, very weird waveforms coming out of two-wire controllers for these systems. So the true RMS meter is very important in that regard. This clamp meter that we sell, the Pro 93, has an RMS voltage measuring function, which is a computing function. Hunter systems have a 1 hertz square wave power feed to the field, which is a very odd thing. Most meters will not read that correctly. You have to have a true RMS meter to read it correctly. It also has a peak hold function, so you can tell it to hold the maximum voltage it sees. That way you can read the real system voltage. Very useful, important things when you're doing this. And as you go into the field, like I said, when you're missing current, or you have too much current, or current's all in one wire instead of the other, you can figure you've got faults to ground out there, you've got cuts in the wire in one side or the other side. So finding valve boxes, open them up, clamp the clamp meter around to see if the currents are what you expect. We talk a little bit about this in our training course. So that's what you end up doing. And this is probably the most important added tool when you're doing this sort of a system. tips I want to mention when you're doing locating. Remember, you cannot find a valve in a system like this because it's behind the decoder. And the trick is in valve location is we're looking for the valve solenoid that activates the valve. And the signal we send out to the field with a locator doesn't make it to the valve solenoid in this case because the decoder is managing the valve, and so the signal's blocked. So you will find the path just fine on one of these things, but you will not find the valve. So you need another trick. Sometimes the valves are handy. They're just kind of along the chain. You follow the path of the wire, and you see the lids of the valve boxes. In a lot of places where the grass grows fast and landscape rock is used or something, they may be covered up. You may have to poke for them. You may have to use the TDR. Sometimes with experience, you can spot the valve box because it's got an extra little bit of coil up of wire inside it, and the splice for the splicing that's done there. So that's another way of finding them. But don't expect to find the valve boxes using a locator the way you usually do. And another thing I want to mention in this diagram, when you're locating a two-wire cable, and you have to know the path whether you're working in this kind of system or not. The control cable path is critical to troubleshooting because it leads you to all your application stuff. When you use a locator, couple only to one of the wires in the control cable, and the other lead goes to ground, just like the most common locating application. But we do not recommend that you connect both leads of the locator across the two wires of the control cable. One of the reasons is that a locator, unless it's loaded down, can put out hundreds of volts, and we don't want to damage any decoders that might be sensitive to that in the system, or cause the lightning protection to activate. So you have to be a little careful when you do some locating. This is that wire radar that I mentioned. It is a TDR in techie terms, and some of you may have used these before, but this takes a little bit of experimentation to learn how to use it well. You can see in the diagram that it sends out a little ping and gives you a waveform trace, and then it has a sliding scale line on there to help you determine how far away the echo is. And the main picture here shows a little test cable I built up that it's 100 feet long with a good splice at 75 feet. So I hook up the wire radar to it, and you can see the picture that it produces. I see a big upward blip at the end, which is the sign of an open circuit. A downward blip is a sign of a short circuit. There are some little cheat cards that go with this, but and then you can see a wiggle that occurs between that big blip and where you started, which is on the left. So I slide my little cursor line out there, and I read the distance, and it says, oh, 100 feet out, I've got an open circuit. And if I slide my little cursor back to where the little wiggle is, I can see at 75 feet, it said, oh, it looks like there's a splice. Pretty handy thing for being able to locate valve boxes you can't find otherwise. With a TDR, you can see a perfectly good splice and see the distance to it. The trick is in calibrating the correction factor for the cable on this device so that the distances read right. A couple more illustrations of signals, transmissions that we did during testing and training. The blip, it's like an old-fashioned radar or sonar system. You send a pulse out from the left and you get a blip coming off to the right. You slide your cursor over and read the distance. If you set the correction factor on the cable correctly, you can find this stuff. So another tool that's available may be necessary sometimes to help find the valve boxes. So providing you don't have good diagrams of where everything is, and a lot of times the valve box will be sidestepped, say 20 feet, and you can't tell that it's off the main path because no one has a diagram that shows you quite right. So especially true when you inherit a system that you weren't involved in the beginning. So that's it. We're trying to keep it short and to the point. You're welcome to send me some email questions, of course, and to look at our YouTube videos. And this particular session, for those that might have missed it or want to see it again or want to get some one of the slides off it, will be available on YouTube later today. We don't intend this to be comprehensive, just to be an introduction. Next week, we're going to talk about checking a conventional irrigation system just by standing at the valve box. And especially important to people as we kind of got to come up on the spring season where we need to do system rehabs. You walk out and say, okay, it's been shut down for the season. I need to stand at the box, and how do I gauge whether this system is still basically running without even leaving the box? That's what we're going to do next week. The week beyond that, because these automatic clamp meters are really pretty handy electrical gadgets, we're going to have a little session on how to use them and how to pick the right one to use. Clamp meters, you can find a meter, like I said, Harbor Freight. $10, it's not going to do so with some of these other things to do. Chances are you have to spend maybe $150, $200 buying a meter, depending on what you're doing. So we're going to talk about that there. So resources. Our YouTube page has got a bunch of stuff in it that very useful things. Over 20 videos that show you tips on locating. If you're using a locator for the first time, you're renting one or something, we have a nice 12-minute video that talks about how to unbox it, hook it up, how to use it, techniques. We have shorter videos for how to find valves, various useful good things. And that's at the Armada Tech channel at YouTube. Beyond that, we also have a little blog where we post application notes and other information, and for that matter, invites to these webinar sessions can be found at the blog. That's at armadaupdate.wordpress.com. You'll be able to see this slide again, of course, when we post it. And I can be reached, I'm Jim Carefoot, and I can be reached at jcarefoot@armadatech.com. So with that, we are pretty much done with today's webinar. Try to always keep it well within bounds here. Everybody's busy, and it's the middle of the day for some people. So I thank you, and if anyone's got any questions, please send me once by the message box, or just drop me an email. I'll be happy to. I very often get a couple questions after these sessions on some particular issue. So thanks for joining us today.